My second video. I'll call it my Hurricane Irma memorial series, and that we're sitting around waiting for Irma to strike. So I made these videos to post on YouTube for in case people are getting ready, trying to deal with hurricane issues and can't come to class. Now let's look at this Excel sheet and examine the algorithm. It's a recursive algorithm, and it's one that computes the value of the number pi. The algorithm is simple. We make a guess at the value pi, call it xn, and then we compute xn plus sine of xn, provided that xn is written in radians, and we set our next guess to equal to xn plus the sine of xn. Okay, then we take this as our new xn value and then do the same calculation over again to get x2 and do the same thing and so on. So I made an Excel spreadsheet that maps those calculations. And what I've shown here is that we make an initial guess, I'll call it x0, and then how the calculations proceed depending on the initial guess. Now, notice how this is set up, by the way, that here's our guess x0, see that? In this case, x0 is given to be 0, which is right here. Now, you may know that the sine of 0 is 0. So if xn is 0, we're doing 0 plus 0, and we get 0 as our next guess, x1. And then, of course, just putting 0 in there again gives us x2 is 0 and x3 is 0, and so on all the way down. Now, if our initial guess is just a little bit more than 0, 0.01, then we do the calculation, 0.01 plus the sine of 0.01, and we get this as x1. So if this is x0, x1 is 0.0199, almost 0.02. Then we take this and plug this into our equation, and the next value for x is 0.039, and then 0.079, and so on. And it keeps increasing from one guess to the next, roughly by a factor of 2, until we get into a value which is pretty close to the true value of pi down here. Now, if we have our initial guess of 0.1, you see it converges into pi much more quickly. So we have a value that kind of looks like pi right in here. Okay, that's at x8. So when x0 is 0, we never get there. When x0 is 0.01, we get there at x11. When x0 is 0.1, we get there at about 8. Now let's look at what the computation is within each cell. So here we see, for example, this cell, the equation in that cell is C4 plus the sine of C4, where C4 is this number. And then this is C5 plus the sine of C5. So this is in fact computing this sequence of numbers. Same thing happens over here. This is D4 plus the sine of D4. That's what you have there. And this is D5 plus the sine of D5, and so on. So you can see as this thing is increasing, our initial guess is increasing, getting closer to the true value of pi. Our initial guess converges much more quickly. Here, when our initial guess is x0 is equal to 1, we converge in after 5 iterations. And it keeps getting better and better as our initial guess increases. Up here, when our initial guess is 6, so it's just under 2 pi. When we have this as our initial guess, we find that we converge into pi in our sequence converges to pi after about x7. Now look at what happens here. When our initial guess is 7, which is actually greater than 2 pi, our sequence converges, but it converges to 9.42477 and so on. This, roughly, this is 3 pi. So we get 3 pi, and we get, if we start with 9 as our initial guess, we get, again, 3 pi. At 12, it converges into 3 pi. At 15, it converges very quickly into 5 pi. And then we have 18 goes into 5 pi. 21, it converges to 7 pi. And then, and so on. So, you see this is 7 pi. This would be 9 pi right here. So you can see how this thing is going. Okay, so that is the way this recursion algorithm works. Now, there's one more thing I want to mention here, and so I want you to try to program up this spreadsheet, but the one more thing I want to mention here is let's try to program this little recursion up. I'm going to do it, let's say, right here. I'm going to put in my initial guess. So let's say 1. X0 is 1. And then right here, I'm going to program in our equation. So I'll say this is equal to this plus the sine of this. So it didn't go in there. Let me go up here. Sine of E19 plus sine of E19. E19, for some reason it was giving me lip. So E19 plus the sine of E19, and I'll hit return. So this is my x0, and this is x0 plus the sine of x0. Notice that's the same number I'm getting right here. Now, if I decide right here, instead of putting 1, what I'm going to do is say, I want to pick my next guess to be this value right here. So instead of 1 here, I'm going to say this is going to equal the value in this cell. Now I hit return, and I get an error. Excel can't calculate a formula. Okay, so I have an error here. So Excel has this circular calculation, and it doesn't like it. However, we can change a setting in Excel so that it will do that circular calculation. And the way it's done, no surprise, where you find the setting is different on the Mac than it is on the PC. On the Mac, I'm going to go to Excel, Preferences, Calculation, and then I'll say Use Iterative Calculation. Okay, now so I hit Use Iterative Calculation, then I return, and what happens is, just using these 2 cells, the computer continues to execute this iteration around and around and around until it converges in. Let's see what happens, for example, over here. So let me just take these 2 values just like this. Okay, now what I want to do is copy this operation over here where my initial guess is, say, 12. Let me just do it here. I'll click on that, and instead of E20, I will pick 12. There, hit return. Okay, so with x0 equal to 12, this is x1. Now, let me put in, this is equal to this, and let's see if it converges to 9.4247, which is exactly what it's converging to over here. So, in fact, you can change a setting in Excel so that it will do that iterative calculation, allowing a cell to reference itself. Now, on the PC, I believe that setting can be adjusted perhaps under the File drop-down menu. But since I don't have a PC here, I'm not 100% sure. So you might want to check it out. So this is an interesting little calculation right here. That is my explanation for how this Excel spreadsheet does that computes this recursive equation. So that's it. I might do another video here in the IRMA